Alright, we're going to do some ancient Egyptian math using the false position method. Here's our equation. So basically what they did was they chose some value for x. And then, depending on what the value was over here, they multiplied it by some number to get 10. Sounds complicated, but it's not. I'll show you. Basically what they did was they chose a number. Alright, it could be 1, it could be 2, it could be 7 million. I am going to choose 5, right? Because if you put a 5 in here, that breaks down pretty easy. Gets rid of the fraction. So 3 times 5 plus 1 over 5 times 5 equals 10 is 15 plus, ooh, that's a 1. And we won't look at this right now, but we'll say 15 plus 1 equals 16, right? So this was our guess, and this is our guess answer. So we are over by 6. All right, so how do we find how do we find 10, right? So this is our guess, we have 5. 16 times some number equals 10. All right, well, we're smart people, and we know that 16 times, 10 over 16, gives us 10, right? Great. So this is, we have our guess, and we have this. So all we want to do now is times those numbers together. We get 5 times 10, can you see it? Equals 50, right, over 16, which reduces to 25 over 8. That's our answer. All right. You want to check it? You want? Okay, we'll check it. All right, let's check our answer. So we're going to use our equation up here. 3 times 25 over 8 plus 1 over 5 times our answer, 25 over 8, equals 10. This gives us 75 over 8 plus, oh, this reduces to 5. 5 over 8, which is 80 over 8, which is 10. Check. All right. Side note, the Egyptians were weird, and they liked to write things in unit fractions. So, how many times does 8 go into 25? 3. What's left over? An eighth. And that's our answer.